Monitoring a fetus's heart rate during pregnancy is one of the main indicators of well-being of the fetus. Commonly, expectant mothers make appointments regularly and visit clinicians for monitoring sessions. With the current enhancements in the technology and also the effects of the COVID-19 pandemic, at-home monitoring devices became attractive, including cardiotography devices for fetal heart rate monitoring. There are various numbers of commercially available home monitoring CTG devices on the market, which brings us to the question, can we trust these devices? Are they accurate as they are claimed to be? There are some publications regarding the accuracy of CTG devices, both in clinical and home settings. However, most of the studies do not make a comparative analysis. They are mostly clinical trials without a setup that could be used to test different devices comparatively. Previous student generations started a project to design a reliable test setup for evaluating the accuracy of home CTG devices. Previous approaches were based on using motors and inflatable balloons to simulate the fetal heart rate. In the new test setup, a shaker is used to simulate fetal heart rate measurements taken in a clinical setting using gold standard CTG devices. The shaker can oscillate with a predetermined frequency pattern. For this purpose, a setup including a microcontroller, a filter circuit, and an amplifier is used to convert and deliver real-life fetal heart rate data to the shaker. To simulate the mother's ureter, a plastic bag filled with water is placed inside a vessel with two holes on the sides. On one side, the shaker is placed, and on the other side, the desired CTG device is attached. The measurement data is sent to a server during measurement, later to be evaluated. To ensure the test setup was free of bias or any systematic errors caused by the shaker, we first evaluated the performance of the shaker by comparing input data taken from a real CTG measurement with the output data we measured with 3D accelerometers placed on the shaker. After concluding that the shaker is reproducing the heartbeat pattern with a high accuracy, test setup was used to evaluate the performance of two different commercially available at-home CTG devices. For a valid evaluation, measurements carried out with both devices were compared to a measurement which was taken with a benchmark CTG device for fetal heart rate monitoring in clinical settings. For error analysis, different methods are used. Here it is shown a Bland-Altman diagram, which is typically used in medical statistics. The average measured heart rate of the home CTG device and the benchmark CTG device is plotted against the error between the measured heartbeats. It is seen that not all the data points lie inside the confidence interval of 95%. With this, we concluded that tested home CTG devices are prone to error, which should not be neglected. In this project, it is shown with this test setup, different CTG devices can be tested and evaluated without needing a real fetus, so that the safety of these devices could be tested in a more standardized way. We would like to thank Professor Martin Daumer and our colleagues at 3M who supported us in the course of this project. And finally, we also would like to thank you for your attention, and we are looking forward to answering your questions.